All right, thank you. So, hi everyone, and thanks for joining. So, my name is Adi Irstein. I'm from Iguazio, and today we're going to talk about Feature Store. So, I'm going to start with talking a little bit of the challenge of managing data within a machine learning pipeline, and then we'll move on to talk about Feature Store. So, what it's all about, what are the benefits of Feature Store, and then we'll drill down to see a live demo. So when we're thinking about a machine learning pipeline, it all starts with data collection and acquisition, right? So we need to get the raw data from databases, from streaming engines, from object store into some place where the data scientists can actually take those raw data and start building features and explore the data. Eventually, come to a point where you can start developing a machine learning models, use those features in the machine learning models, and finally have a model that can be deployed in a serving layer. And once you deploy the model in the serving layer, you also need to enrich the data, enrich it with a feature vector, and monitor the data that goes into the model and is being used in the production database. And in some cases, compare the data with the data that goes to the training in order to identify if there is any drift or any deviation from the trained data set and production data set. So the bottom line is that it's all about data. So most of the complexities of building machine learning pipeline arise from the data, because you need to take the data from different sources. Usually in the research environment, it could be a small subset of data using a Parquet file or CSV file, but when it goes to production, it's a completely different game, right? You may need to take the data from databases, from streaming engine. So you need to know how to take the data, build the feature engineering part, do all kinds of transformation, create the model, and then again, once you deploy the model, you still need to use the data in order to enrich your feature vector, and last but not least, monitor it. So a big part of the game is data handling, and this is where the complexity comes from. Now, on top of that, you have this process where you have a couple of disciplines in the game. You have data scientists, you have data engineers, you have MLOps engineer, and when data scientists start exploring the data, they need to take the data in the research mode. They need to take the data from a data lake or from an object store, or they use a Parquet file. In some cases, even in that phase, they need to go to the data engineers to get some help, and then they build their model. But the thing is that once they have the model, how do they take it to production? That's the real thing. And in order to do it, they need to go back to the data engineers, and in many cases, re-implement the feature engineering pipeline again in order to take it all the way down to production. Because again, in production, you may have different type of data sources. It's not just a Parquet file or a CSV file. Now you may need to take data from a live streaming engine. You may need to take the data from an OLTP databases. So you may need to write or rewrite an entire online transformation again. Put the data in an online database so it can be used by your machine learning model running in a serving environment in an online fashion. So there are lots of back and forth between the data scientists and the data engineers, even DevOps, in order to take what they built from research all the way down to production. And the DevOps guys needs to take care that everything is set. You have a monitoring environment in place. You have a CI/CD. You have a full-fledged environment where you can run things at scale. You can scale up. You can scale out down. You can monitor it. So there are lots of stuff that needs to take place in order to take it from research to production. And this is where the feature store comes to the table. Basically, the idea of the feature store is to address most of those challenges. And a feature store is really a change in that paradigm. Because if you think about it, a feature store is some kind of a single pane of glass where you can actually create features, manage features, deploy features in a centralized place. And as a data scientist, when you start your project, you don't need to start from scratch. You can go to that catalog, you can search for existing features, and you can basically reuse those features, instead of writing those features from scratch again and again and again. Now, not only that, but the beauty of it is that when you work with a feature store, you basically define the logic of the feature engineering once. You don't need to do it again when you deploy the feature engineering pipeline in production. You basically define the logic once, and the data goes to both an offline feature store, usually for CAD file, and it also goes to an online feature store in order for online serving. So you don't need to re-implement the code again and again and again, and that's a pretty big benefit, because that really accelerated the time that it takes you to move things from development to production. Now, not only that, but you're also avoiding the train serve skew, because if you're using the same logic for your training and for your serving, you don't need to rewrite it again. You're basically avoiding those skewing that you may have if you need to rewrite things again and again and again. Now, the other thing is that a good feature store is also integrated with the monitoring, the model monitoring layer. So you have the data that comes to the model in a real-time serving environment. You have the features that were trained in the feature store. Now you can compare between them and easily identify if there is a deviation, if there is a model drift or data drift based on the data that was trained and data that is actually going to production. And you minimize those back and forth between the data scientists and the data engineers and the DevOps. You write your logic once and it's ready for production from day one. And the feature store can be used for training your machine learning pipeline. It can also be used for serving and for monitoring. So that's a pretty big change in the paradigm if you think about how do you create a machine learning pipeline down the road. Now, the tech giants figure it out, right? They already created their own machine learning data science platform. So Uber has their own, Michelangelo platform, Netflix has their own stack, Twitter, and so on and so forth. So they put lots of focus, lots of resources in order to build that, and they have those resources and the money and the time and the capabilities to do it. But what we want to do is basically to make it available for any enterprise. So we believe that any enterprise can benefit from having a feature store and a full-fledged data science platform that can support those type of feature engineering, and this is exactly the promise that we're talking about. So again, in a very high level, feature store is a single pane of glass where you can manage all of your features in one place. As a data scientist, you can go to a catalog of features, you can search for features, you can reuse features, you get to see all kinds of statistics and analysis on those features, link from those features to the model, and easily identify if there are features that are not being used or features that are mostly being used, and so on and so forth. But more than that, the feature store is not just a catalog, it's also a very robust data transformation service. So as a data scientist, you're getting a very easy to use API in order to do all kinds of data transformation. So you can create, aggregate to the sliding window, you can do filters, joins, all kinds of things in a very, very simple API. Under the hood, it knows how to leverage different engines and basically run those feature engineering at scale without the overhead of the data engineers. So you really minimize the overhead of the data engineers and provide basically by getting this data transformation service, you can minimize the work that you need to do in order to prepare those features for production. So let's move to see the demo. Okay, so I'm going to show you in this demo kind of a walkthrough of our feature store. What we're going to do is we're going to create a project called stocks demo, and then within that project we have three data sets. So the data sets are quotes, trades, and stocks. The quotes basically comprises of ticker, timestamp, bid, and ask. The trades comprise of timestamp, ticker, price, and quantity. And the stock is like a lookup table with the name of the stocks and the exchange name. So you can see that data here. Those are the feature set. That's how it looks like, the quotes, the trades, and the stocks. Now, with our feature store, we basically support a couple of engines. So we support Spark, we support Pandas, and we support an engine that is called Story. Story is basically a stream processing engine that is very, very good with complex real-time processing. So in this demo, I'm going to show you how we work with the Story engine. And the first thing that you want to do is basically to run some imports. So we're using an open source tool that is called MLOps that we're driving, which is part of the solution. So you need to run some couple of imports. And then the way to define a feature is the following. You just need to set up or run this command feature set, give it a name. In this case, I'm going to create a very, very basic feature set called stocks with an entity called sticker. Entity is basically the key of this feature set. And when you create a feature set, it basically by default goes to two places under the hood. It goes to a Parquet file, which is the offline feature store or feature set, and then it also goes to a very fast key value database for online survey. So that's the ingestion by default. Obviously, you can change that. You can change the target, and you can put a target in different places, or you can work with just offline or online if you want to change the default. And after you define the feature set, all you need to do is to run the ingestion command. Basically, the data source is the stocks data frame. It goes to the stocks set, and now we have a feature set, very simple one, with a ticker, name, and exchange, and this is the feature set that we built. Now, let's create a more advanced and complex feature set. Now I want to take the quotes data frame, and I want to run real-time or live aggregations and transformation on top of it in order to create my feature set that later will be used as a feature vector. Now, in order to do that, again, we're going to use this story engine. This is a stream processing engine that can handle very complex transformation in real time, very efficient. And the first thing that I need to do is basically to create this feature set that is called stock quotes, give it an entity. Again, this is the ticker name. That's going to be used for joins later on. And now the first step that I want to do is to create a custom class. So this is a very kind of simple Python code. What I want to do here, I want to create another column that is called multi, which is based on the event that is called build, and multiply that by something. So I'm writing my custom class here. It could be anything. Obviously, it's Python code. And now I need to work with the story graph in order to add it into the actual graph that is going to generate the feature set. So the graph terminology start with the feature set name, and then you add .graph.to, and this is where you define the steps within the graph. So the first step is to call my class here, my map, give it a value, multiplier equal 3, and then I want to do a couple of other things. So for example, I want to add another column that is called extra. So we have built-in libraries within story to do all kinds of things like running a Lambda function or doing some filters and stuff like that. So this is how I define it. So we have this function that takes this event that is called bid, multiply that by 77. Then the next step is to filter the data. So I want to filter the data that goes to bids that are greater than 51. And the next steps of the graph is to do some validation. I want to make sure that the minimum of the bids is 52, for example. If not, I can trigger notifications, events, all that kind of stuff. And the last piece of this graph here is I want to create a sliding window aggregation. That's really easy. All I need to do is to use this add aggregation command, give it a name, give the function name, sum, max, the time window. In this case, I selected 1 hour or 5 hours on a sliding windows of 10 minutes. So every 10 minutes, I'm going to create that sliding aggregation. I can give it an alias, and the column name is going to be concatenation of the alias with the formula with the time window. And so let's run it, and I can see the graph. So the graph starts with my custom class. It goes to this story extend, filter, validation, and eventually the aggregation. Now, before I run this ingestion, the full ingestion, I want to do some simulation. So in order to do that, I run this infer metadata. We're going to change that, by the way, to a preview, and I give it the feature set name, the quotes underscore set, the data frame itself, which is the quotes, the entity column, and the timestamp. And now I can, simulate the data. So just run it again. Okay. Can I skip some steps here? So Okay, and now I can see the data itself. So we can see the aggregation here. So we have all those aggregation, the ask and the bids with 1 hour and 5 hours aggregation, the timestamp, the bid, the ask, and those new columns, the multi and the extra that are part of this feature set. So now life is good. I am happy with the feature set. Now I want to ingest the data into the feature set itself. And when I run this ingestion under the hood, that's going to run a job that basically save the data into this quotes feature set. And now we have this quotes feature set. When we go to the user interface, we have a very robust user interface, so you can actually see the feature set. Let's go to the project stocks demo, to the feature store view. And here we can see our two feature sets, the stocks and the stocks quotes. If I drill down from the stocks quote, I can see all kinds of metadata, description, label, version, URI, also the commands themselves in order to fetch the data. Then we get to see the features themselves with some information, the feature name, the type, also the validators is here. I can get to see the transformation as well. So this is the transformation graph that we saw in the Jupyter notebook. You can actually go to specific transformation and take a look at the code and the logic of that transformation. We can preview the data, so you get to see the preview of a data set. And we also run some statistics on those data sets as part of the feature store solution. So now we have a feature set ready, and what we want to do now is to create a feature vector for our models. So the feature vector that I'm going to create is a feature vector that comprises of 3 tables. So I'm going to join the stocks, the quotes, and the trades using a time travel join, because the timestamp of the quotes and the trades are not exactly the same. So we need to do time travel join. So I need to define the list of features, and you can see that we can take features from different feature sets. So it can go from the stock quotes and the stocks. And now we have the feature vector, and we need to define feature vector. So we give it the name, the stocks vector, the list of features, a description, and now we have a feature vector that we can work with. You can either save it, or if you don't want to save it and just an interactive session, you can avoid saving the feature vector. And if you want to take the data as a data frame and basically start working with it for a training job, you need to run this command, get offline features. Now we give it the feature vector, this list of features, and also the entity roles, which is the trades data frame. Basically it's going to join the trades data frame. That's like the live events that are coming into the feature vector, joined with this feature vector that I just created based on the entity timestamp time and the entity column itself, which is the ticker. So when we run it, we can basically get the feature vector, the name of the ticker, the exchange, and all those aggregations and the columns that I just fetched as part of the feature vector. So this is how I can actually work with a data set right now that can be used in a training environment for training my machine learning model. I don't need to rewrite the code or anything like that. We have a feature vector ready, and now we can just start using it. And by the way, if you go back to the user interface into the feature store, you can also see that feature vector. You can drill down and see all the definition of that feature vector, the requested features, the actual features that were returned, because there is a difference between the feature that you're asking and the actual returned features, statistics, and we have all kinds of information about them. And by the way, the UI is not just read-only. You can actually create feature set and vector from the UI as well. So this is for the training environment. Let's say that I want to access those features for an online application. What I need to do is to create an online service for that specific feature vector. Again, I don't need to write anything else. It goes to the feature store, the offline feature store, and also to the online feature store when I do the ingestion. The only thing that I need to do is to run this service. And once I have this service, I can run some statistics and take a look at the statistics of the service. And if I want to actually read those features in an online manner, I just need to run this service.get. Now I'm getting all those features for the key, Google and Microsoft, including the aggregations and all its transformation. And this is how I'm going to use the features in a serving function. So that's just an overview of how you can create feature set, combine a couple of feature set, create a feature vector, and then use it for training and for serving as well. And again, you can go back to the user interface, and here you can do all kinds of things like searching features, across the board. It could be based on name, based on labels, all that kind of stuff is basically supported. Now, if you're looking for more advanced type of feature store capabilities, you can go to the end-to-end demos. I really encourage you to go to docs.ml1.org. Over there, you're going to find lots of information about the feature store and other parts of the system, including this basic feature store example and some advanced examples. In the advanced example, you're going to see how we can actually create feature sets that comprises not only from a data frame, but also from a file and from real-time engines, and how you can actually get streaming into a feature set, how you can define it. So everything is there. If you go to this notebook, you can see how to set up a resource like HTTP resource and basically create a feature set that gets events in real time. And that's one of the most important capabilities of our feature store. Then in the second notebook, you can see how you can run a training job using the feature vector. So you define a feature vector, and then you have an example of how you can actually use that feature vector when running a real training model. And once you have the model, how do you actually use that in a serving function? How do you read the data from the feature vector in an online manner? So you can find some nice examples here as well. Okay. Now, so I really kind of encourage you guys to go to our booth. We'll be more than happy to answer your questions and get in touch and provide you all information that you want to ask about our feature store. I also want to take that opportunity and mention that we also started a hackathon recently. It's called MLOps for Good. It's basically based on MLOps. So the idea here with this hackathon is not like a typical hackathon that focus on building the best machine learning models or things like that. It's mainly around MLOps and the ability to create a production machine learning pipeline. So I really encourage you to take a look at it. The hackathon theme is all about bringing the data science to production for social good and focusing on MLOps. So just go to iguazio.com hackathon. You see all the information over there, and we'll be more than happy to see you there. So that's pretty much it on my end. Thanks everyone. I hope you enjoyed the session.